Hello, everyone. Welcome to VCIA training course. The subject of today's lesson is an introduction of NMS Basics. This lesson is mainly divided into 4 parts. The first part is an overview of NMS, the second part is an overview of SNMP protocol, the third part is a brief introduction of the new NMS of VSOL. And the fourth part is an introduction of the NMS app. After this lesson, you will be able to Number 1. Understand the basic architecture of an NMS. Number 2. Understand the communication mode and interaction between Network Manager and Network Element. Number 3. Understand the basic settings of SNMP. Number 4. Understand the basic functions and operations of VSOL, NMS, and app. Now let's start with the first chapter. As the network scale expands and the network complexity increases, it's more and more difficult for us to manage an entire large-scale network only by manual operations, which necessitates the emergence of an NMS. In network management, the devices in a network are managed to support the normal, cost-effective, reliable, and secure operation of the communications network so that effective, reliable, and secure communication services can be provided. Network management system is an important part of a communications system. The main objectives of this chapter are as follows. Number 1. Describe the basic architecture of an NMS. Number 2. Describe the communication mode and interaction between Network Manager and Network Element. The basic functions of the NMS include fault management, security management, and configuration management. Fault management includes fault detection, fault diagnosis, fault rectification, and fault recording. It is used to detect and determine faults in the network environment. Faults can be identified by detecting abnormal events recorded in logs and traced, diagnosed, and tested based on fault symptoms. The security of network management can be divided into 2 levels: the security of equipment and the security of network management. Its management methods mainly include user rights management, user login management, log management. As for configuration management, network administrators can centrally monitor and manage switches, OLTs, and ONS through the network management platform and configure their services. The common network management software application architecture modes include CS architecture and BS architecture. In the CS architecture, the application is divided into 2 parts. One is the client software, installed on the user's personal computer or mobile device. And the other is the server side, responsible for data management and processing business logic. The client and server communicate through the network. The client initiates a request. The server responds and processes the request and returns the result. The CS architecture is built on a dedicated network for a relatively fixed user base and has high information security. But it is more difficult to maintain and upgrade than the BS architecture. Then, let's start with Chapter 2. Simple Network Management Protocol is used by the NMS to communicate with the agent. This chapter describes the basic concepts and configuration methods of SNMP. The main objectives of this chapter are as follows. Number 1. Describe the basic structure of an SNMP. Number 2. Describe the basic settings of SNMP. Simple Network Management Protocol is a standard network management protocol widely used on TCP/IP networks to monitor and manage the status of network devices. SNMP uses UDP as the transport layer protocol. Because UDP has no connection and low communication overhead, it is suitable for network monitoring. The NMS can remotely configure network device parameters. Network devices can also actively send traps to the NMS to notify specific events or abnormal states. SNMP provides a way to centrally manage network resources through a network management station running the necessary software. It ensures that management information is transmitted between any 2 points independently of the managed device. Currently, SNMP-v2c and SNMP-v3 are commonly used protocols. In fact, there are 3 versions of SNMP: SNMP-v1, SNMP-v2c, and SNMP-v3. SNMP-v3 is similar to SNMP-v1 and SNMP-v2c in implementation principles. The difference is that SNMP-v1 and SNMP-v2c use read-only and read-write community names for connection, while SNMP-v3 uses authentication and encryption for connections, adding authentication and encryption. The Simple Network Management Protocol typically listens on 2 main UDP ports, 161 and 162. The former is the port used by the SNMP agent to receive GET and SET requests from the NMS and send responses. Port 162 is the port used by the SNMP agent to send trap to the NMS. It should be noted that vendors may have proprietary implementations that may use other ports, such as 199,391,705, 1993, etc. But this is not standard practice for SNMP. In most cases, ensuring that ports 161 and 162 are open and configured correctly is sufficient for SNMP to function properly. SNMP manages network devices through MIB operations, such as get, read information, set, change information, get next, read the next variable instance, and trap. The agent sends event alarms to the NMS. SNMP Management Information Base, MIB, is a core concept within the SNMP framework. It is essentially a database structure that defines a standard set of rules and formats for describing the various objects and their properties that can be managed on network devices. These objects can include device configuration information, status data, and statistics, such as network interface traffic, system uptime, and CPU usage. SNMP manages network devices through operations on MIB, including get, set, get next, and trap. Now let's learn how to configure SNMP on VSOL OLT. The SNMP community performs authentication and authorization to ensure that only authorized NMS can exchange management information with network devices. OLT has two community name configurations by default, public and private. They correspond to read-only and read-write-write. In Add Community Interface, you can add SNMPv1 or SNMPv2c read or write community names. In the Community Table interface, you can view or delete the community names that have been created. In Add Trap interface, you can enable or disable the device to send traps to the NMS. After Enable Trap function, any abnormalities or modifications of important data on the device will be reported to the NMS server as events. In the Trap Table interface, you can view or delete the trap rules that have been created. In Chapter 3, we will learn about the NMS of VSOL. The VSOL Intelligent Network Cloud Engine (VSOL INS) is a network management platform based on BS architecture. The VSOL INS is capable of monitoring and managing OLT and switch, as well as supporting the MQTT protocol for monitoring the running status of ONU. Then it also supports Android app and iOS app management. This chapter introduces its installation, basic functions, and features. The VSOL INS app will be covered in Chapter 4. The objectives of this chapter is: describe the basic operation and function of VSOL INS. First, let's take a look at the installation requirements for VSOL INS. It is required to run on a Linux system, and the version is not lower than CentOS 7. The more devices you manage, the more memory it requires to run. You can refer to this table. Please refer to the attached figure for the installation process of VSOL INS. Select hardware devices based on the network environment you want to manage. Before installation, disable the firewall or antivirus software of the device, or whitelist the installation software and installation path. Refer to the user manual for detailed installation instructions. After the software is launched through the script, we can access its web on the browser. It should be noted that the default port for its web is 38880. The default username and password are admin and VSOL at 2024. The main functions of VSOL INS include performance monitoring, alarm management, device management, privilege management, topology management, and data backup management. These features are briefly described later. After logging into VSOL INS and accessing the home interface, users can access statistics for connected devices and their alarm. Now let's learn how to connect OLT to VSOL-INS. In general, the OLT can connect to the NMS server through both in-band and out-band management IP addresses. In band management, you need to configure VLAN IP address for the OLT, and then configure this VLAN on the OLT uplink port through which the NMS communicates with the OLT. If the VSOL-INS server and the OLT IP address are not on the same network segment, it would cause the OLT to be unable to access the server. You need to configure a gateway or static route for the OLT. Then need to configure the VSOL-INS server IP on the OLT remote server interface. If the connection is successful, a tip will be displayed. If it's not connected, you can check whether the OLT can access the VSOL-INS server by ping. Finally, log into VSOL-INS to check whether the OLT is online. As for out-band management, it is very similar to in-band management. The only difference is that it connects to the server by manage port. If you want to delete the OLT on the connection, there is a delete button in the operation list. You can click on it. However, if the link is normal, the OLT still reconnects automatically. Now let's learn the basics of OLT management on VSOL-INS. Click the Manage button in the target OLT to access the specific configuration interface. On the Device Information interface, you can visually view the statistics and running status from the statistics chart. Basically, VSOL-INS supports most of the functions of configuration management VSOL OLT. You will find that it is very similar to VSOL OLT Web, which means that you will be able to use it quickly if you have used VSOL OLT Web. By clicking the Alarm button in the target OLT, the alarm details list is displayed. You can view the alarm events related to this OLT and choose to confirm the alarm and export them. As for OLT upgrades, you can directly select the target in the OLT list and follow the instructions to upgrade. Or you can upgrade on the OLT management interface. And it is also very similar to the configuration on OLT Web for other service configurations on VSOL-INS. There is no specific introduction to this course. You can refer to other courses. PON Products Basic Operation and Configuration. Now to the ONU surveillance section. The VSOL-INS offers two methods for monitoring ONUS: indirect management through the OLT, and direct interaction with ONUS via the MQTT protocol. The latter method requires that the ONU also supports the MQTT protocol and needs to be configured with the MQTT server IP in order to access the VSOL INS server. You can view the connection status of the ONU in the ONU list. As with the OLT list, the green status indicates that the device is online. Red is offline. Click the Manage button to access the Overview interface. You can view detailed information about the ONU, including the software version, optical power, device port status, network information, and more. Performance monitoring is an important function of NMS. In VSOL INS, you can customize and establish monitoring policies and allocate them as needed, saving resources. For example, you can choose to monitor an OLT periodically and customize performance metrics. On the Monitoring Data interface, you can view the current monitoring data in real time to determine whether the device is working properly. Click the Real-Time Monitor button. You can enter the Monitoring Data Details interface to observe the changes in device monitoring data over a specific time period, which can serve as reference data for deployment. VSOL INS supports the automatic generation of a base topology based on OLT registration. You can also add splitters as needed to modify the topology to better match the actual connections. Alarm management is also a basic function of an NMS. You can view the alarm events of OLT or switch connected to the server in the alarm list of VSOL INS, and take necessary actions to confirm and clear alarms. VSOL INS can push alarm information to users by email or SMS. You can find related configuration items on the Alarm Config interface. It is convenient for user to handle the exception on time. VSOL INS supports the display of device location through maps. On the Map Management interface, you can mark the device to the corresponding location, but you need to fill in the API key provided by Google in the Map menu first. VSOL INS introduces the concept of domain groups. Administrators have the ability to categorize network devices into distinct groups and allocate access privileges to users based on their respective roles for easier access management in the future. VSOL INS provides a custom menu function, which you can modify the menu description, icons, sorting, and whether to display this menu. Finally, let's start with the last chapter. when the administrator uses a mobile device to access VSOL INS web. The management interface is inconvenient to operate. VSOL has developed apps for Android and iPhone to manage network device. After this chapter, you will be able to describe the basic function of client app for VSOL INS. The Android app of VSOL INS is required to run on devices with Android 13.0 and above. Running on iPhone requires iOS 15 or above. After entering the login interface of the app, you also need to configure the VSOL INS server IP and port number. It should be noted that the port number is 38881. Now, let's learn how to manage devices in VSOL INS app. After logging in to the app, the home interface will be displayed. It displays the count of active OLTs and ONUS as well as alarm statistics. On the OLT interface, you can view the OLT list information on the server. The green status indicates that the device is online. Red is offline. Click the Manage button to enter OLT overview. You can view the basic device information, which includes software version, device running time, CPU, and memory usage. Click the Config button to enter OLT configuration interface. You can do basic configuration of OLT ports. Click the alarm icon. You will view the alarm list of the device. On ONU interface, you can view the ONU connected to the VSOL INS server through MQTT. Click the button to view the specific status information of the ONU. It includes software version, device running time, CPU, and memory usage, device port status, optical power, and more. On System Interface, you can modify the password of the login account and server IP, as well as some other basic settings of the app. That's all for this course. Thank you for your attention and listening.